Before watching the video, don't forget to subscribe to our channel by clicking the subscribe button below and clicking the bell icon to be notified whenever we publish a new video.
The direction in which a cylinder piston will move or a fluid motor will rotate can be controlled by the direction of flow into the device. A cylinder is said to reciprocate if its piston travels back and forth, being reversed automatically at each end of its stroke without human operator attention. In an air cylinder, automatic reciprocation can be stopped by an electrical action or by a shutoff valve in the airline. If stopped by electrical action, it will continue to travel until it reaches one end or the other of its stroke. If stopped by shutting off the air, it can be made to stop anywhere in its stroke. Fluid valves are typically described as being either in the open or closed position. As described, the open position allows the flow of fluid, while the closed position prevents flow. The normal position of the valve is defined as the position of the valve when its spool is unshifted and the power is off. This means that any mechanical actuators, such as springs, are in their non-actuated positions. Electrical actuators, such as solenoids, are powered off. The normal position can sometimes be referred to as the unshifted, de-energized, or unactuated position. Valves that do not have mechanical or electrical actuators do not have a normal position because they must be manually moved. When shifted, they remain in that state until manually shifted to another position. The terms normally opened and normally closed are used to describe the condition of a valve when it is in the normal position. For this valve, the normal position allows unrestricted fluid flow through the open ports. Therefore, this valve is a normally open valve. As with fluid valves, electrical switches also have a normal state. In this case, the limit switch is operated by the movement of the cylinder rod. When the cylinder rod extends, it moves a cam which makes contact with a lever that actuates the appropriate switch. The limit switch regulates the electrical circuit that controls the cylinder. Wiring diagram graphic symbols for limit switches are used to identify both its location within the electrical circuit and the state of the switch contacts. The most common contact symbols show whether the switch is normally open or normally closed. As before, a switch is considered to be in its normal state when it is unshifted with the power off. While a normally open valve allows fluid to flow, a normally open switch prevents current from flowing. Electrical current can flow across the switch as long as both sides are touching contactors. Circuit diagrams are typically depicted in their normal off state before any work has been accomplished and no cycles have started. If the switch is drawn above the circuit line, it is a normally closed switch. If the switch is drawn below the line, it is normally open. Adding an arrow to either illustration indicates that the switch can be held open or closed. For example, consider the limit switch, which is an electrical switch operated by the motion of a machine or presence of an object. In this circuit, there are two limit switches. Limit switch 1LS is a normally open switch. The arrow shown next to the switch indicates that the limit switch is normally opened, but is held closed prior to the start of the cycle. The other limit switch in this diagram is 2LS. It also is a normally open switch. However, at the start of the circuit, it is in the open position and thus has no arrow. A holding relay is a necessary part of this circuit. Its coil is shown as a circle marked 1CR. Holding relays typically operate one or more relay contact sets. In this diagram, the holding relay operates one set of contacts. The contacts are depicted as normally open. As with switches, they can also be manufactured as normally closed, with a slash mark depicting the normally closed state. This particular circuit illustrates the electrical relationship between limit switch 1 and 2 and solenoids A and B. When the start button is momentarily pressed, relay coil 1CR becomes energized, allowing contacts 1CRA to be closed and connected. This allows the relay to hold a circuit through the stop button and contacts 1CRA. Once the contacts are closed and connected, the coil will remain energized even if the start button is released. When contacts 1CRA are closed, electrical power is distributed to the rest of the circuit. Since limit switch 1LS is held closed by the cam prior to the beginning of the cycle, current flows through this switch and activates solenoid A. Since limit switch 2LS is open prior to the beginning of the cycle, current cannot flow, and thus solenoid B remains de-energized. Solenoid A operates the hydraulic valve, which shifts to allow fluid to flow and extend the cylinder. As the cylinder extends, the cam releases limit switch 1LS, which in turn de-energizes solenoid A. However, since the valve has no spring returns, it remains in its shifted position when both solenoids are de-energized. As the cylinder continues to extend, the cam engages limit switch 2LS. When limit switch 2LS is closed, solenoid B becomes energized. Solenoid B then shifts the hydraulic valve, allowing fluid to drain from the blind end and begin to fill the rod end of the cylinder. The rod and cam begin to retract until the cam engages limit switch 1LS and the cycle starts anew. When the stop button is pressed, the relay coil becomes de-energized and relay contacts 1CRA open, disconnecting the circuit. This removes current from the entire circuit and de-energizes both solenoids. With both solenoids de-energized, the hydraulic valve remains in its current position and the cylinder will continue to travel in its current direction until it reaches the end of its stroke. Since there is no power to the limit switches to engage the solenoids of the valve, the cylinder remains in its current position. Depending upon when the stop button is pushed, the cylinder may stop in either its extended or retracted position. Understanding how electrical circuits impact fluid machine components can help designers and technicians develop the most effective systems for each unique requirement.
Thanks for watching. If you like the video, give it a thumbs up and share it with your friends. For more tutorial and tips, subscribe the channel.